Okay, hello. Okay, I wanted to go through the normal distribution. That's what it's called. It's all the stuff with the Z scores. Okay, I'll start with this thing. I'll zoom in a bit. This pattern, this just tends to happen for any whenever you got some, I don't know, a whole bunch of data, you tend to notice this shape, this pattern. Okay, the mean could be anything. It really depends what you're measuring and what it is. It could be the average height, the average mark in a test, the average age of a group of people. But then there'll tend to be, a peak, and then there'll be some others higher, some others lower. And these gaps we use the standard deviation. Okay, and it turns out if you measure the mean and the standard deviation, there should be about these percentages in each group. I'll just show you. These are the percentages that normally come up. Whoops, 68% between 1 and -1. And they're throwing in these words like mostly. That's about 2/3. And then very probably, and then almost certainly. These words are pretty arbitrary, that wording. I'll just show you in the formula sheet, right? This is from last year, 2015, so hopefully you'll get pretty much the same thing. These are the percentages that they'll give you in your sheet. Okay, but see, if you halve 68, you get 34. That'd be between 0 and 1. The normal distribution is symmetrical. Same for halving that and halving that can be quite useful. That's where these numbers came from. Okay, so for example, if you halve 95%, that tells you how big this area is between 0 and 2. Because 95 is between -2 and 2. So if you halve it, you get this part. And then if you halve 68, you get this part. So anyway, I'm just going to skip down, just do the summary questions, and we'll see how it goes. Okay, so what is the Z-score if x equals 20? So the score is 20, the mean is 16, and the standard deviation is 4. Okay, this is really easy. I want you to connect it with common sense. There is a formula, but the formula is useless if it makes you do something complicated. I instantly know the answer, okay? Their score is above the mean, so I know it's positive, so it's not these two. How much above the mean? They're just 4 above it, right? But 4 is the standard deviation. So they are 1 standard deviation above the mean. So the Z-score is 1, okay? If you did it with the formula, which again, the reason I'm able to remember it is because I understand it. Whoops. Actually, what I want is the Z. So you compare their score to the. I'm not sure how to best do this. Over S. Okay. All that says is compare their score to the mean, and then see how many standard deviations is it. Okay. In this case, it was 20 take away 16 divided by 4. 4 divided by 4 is just 1. Okay, let's keep going. Well, actually, just with that one again, if their score was 16, the Z score would be 0, because that's the mean. Okay, if their score was, say, 10, then it's below the mean. Okay, 6 below, 6 divided by 4 is 1.5. So if x was 10, the Z score would be minus 1.5. Okay, alright, let's keep going. How many scores have a Z score greater than 2? Okay, I might have to skip that only because I don't have a calculator. Oh man, if these have a lot of... Hang on, can I pause this? I don't know if I can pause. Alright, look, I'm just going to keep going. So I can't tell, but if what you would do is put those in a calculator, enter them into the statistics thing, okay? Using all those steps, and then you'll have to find the mean, find the standard deviation, and then figure out. So for example, I'm just going to estimate it for now to try to help. Let's just say the mean was 60. Let's just say 60. I can't tell. And let's say the standard deviation, so I'll call that No, never mind. X, okay. So the mean is 60, and let's say the standard deviation is about 12. I don't know, it's just an estimate. It might even just be 10-ish. Okay, just estimating it. Let's just say that. Then a z-score of 2 would mean 2 standard deviations above that. So 1 standard deviation above would be 70, add 10 again, it's 80. So how many above 80? None. So I reckon that's probably wrong. Maybe the standard deviation is like 7 or 8. Let's just say 7. 2 lots of that would be 14. Added to 60 is 74. So how many are more than 7? Oh, I didn't see the 96. That affects things. But anyway, you have to use your calculator depending on what numbers you get. Sorry, I don't know the numbers for that one. Maybe I'll do it later. Okay, Susan scored 80. The mean was 70, so she's above the mean. And the standard deviation was 5. So she's 10 above, which is 2 lots of 5. So her z-score is 2. I'm just going to write that. Her z-score is 2. And then it's rescaled. Okay, so they're going to make it so the mean is 60 and the standard deviation is 8. So her z-score will still be 2. So we're just going to start with the score now. So it's going to be 60. But we just need to add 2 lots of 8 to that, because her z-score is 2. Okay, so that's 16, 76. So just remember the z-score, it's like a scale. It's saying, are you on the mean, are you above or below, and by how many standard deviations. Okay, yeah, that's her new score when they rescale it. Okay, he got 2.5. Okay, this one's very similar. So the mean was 58, he's above that, so plus 2.5 lots of 6. Okay, so 2.5 lots of 6 is 12, plus 3 is 15, so 73, I think. And it's a percentage, I guess, in the test, so 73% D. Okay. Okay, so Zoe got above average. Okay, so 76 is 16 above 60. And that's just 2 lots of 8. So okay, I don't know if this is Zoe or just some. It's just a stock picture. I don't know why they use these pictures. It's irrelevant. So Z equals 2 for science. Okay. What about for history? The mean was 56. To be equivalent. Okay. So if she got Z equals 2 for that one, her mark in history would need to be, so 56 is the mean, so she needs to be more than that. 2 lots of 12 is how far above. A z-score of 2 is very good. It means you're right at the top, or near the top. Z-score of 3 means basically you are the top. There's only 0.15% above you. Okay, 2 lots of 12 is 24. So I think that's 80. Okay, so the 76 in science is equivalent to a mark of 80 in the history. Notice the history has a lower mean but a much bigger standard deviation. It's much more spread out. Whereas science, it's a bit higher but it's a bit closer together. Alright. So then the age, younger than 64. Okay, so it's one of the percentage ones. So notice 67, I think I said 64. 67 is above 53, and it's 14 above. So it has a z-score of 1. Alright, now remember with the percentages, whoops. So between -1 and 1 is 68%. Okay, let's just maybe write that. -1 to 1 is 68%. So from 0 to 1, just if you take half of that, 34%. Okay. So we're looking at anything up to 1. So if you think about it from the middle, let me maybe go back quickly. This is so 0. This half should be 50%, and this is 50%. We're looking at everything below 1. Okay, this area. So we've got 50% plus this one, which is 34%. So what percentage are less than a z-score of 1? Should be 84%. Okay, same if you went up to 2, you just take the minus 2 to 2 number, so like 95%, halve it would give you this, just these two parts, and then you add 50%. I don't know if that makes sense, but anyway, so we're going to do 50% plus 34, whatever, 50 plus 34, 84%. Okay, where is it? So that's the answer for this one, and that's because it's a z-score of 1. I figured out just because it's 14 above, and that's the standard deviation. Okay, what percentage are between 0 and 3? Okay, so again, we'd take the minus 3 to 3 number, so that's 99.7% are in that range. So 99.7, and then we just need to divide it by 2 because it's symmetrical. So that'll be, thinking of a quick way to do it. Wait, no, I don't think that's right. 0.3. Okay, I'm pretty sure it's that. 49.85%. Okay? I'll just do it on the calculator as well. Cool. So, yeah, that's the answer. Where does it say? Yep, 49.85%. Alright, the results of a literacy exam were normally distributed. Okay, this one's actually the same as this one, the 84%. That is the answer. 84%. By the way, I haven't looked at these, so if you understand it, you can get the answer straight away. So for this one, we figured out this 67 is a z-score of 1. How many are less than that? Let's go to the graph again. It's going to be this section, 34%, plus this whole half. Okay, for this one, it's saying how many are more than minus 1. It's going to be this little section, 34%, plus a half. That's the same. So it's going to be 84%. Okay, so 84% for that one. Okay, the mean's 20 in the standard deviation. Okay, so I can do some of these pretty quickly. I'm going to delete all this. So, yep, so the z-score. For this, you can sort of use a formula. Actually, this one I can tell the z-score is just 2, because this is above that, and it's just 6.4 is just 2 lots of that. But anyway, let's say we did the formula 26.4. Take 20 away and divide by 3.2, but that'll be 2. Okay, so that's the z-score for the first one, is 2. This one may be harder to tell. Now the order is important. It's going to be negative this time. I actually can't tell what it is. Oh, I can. I think it's minus 1.5. Let's just do it. And then over 3.2. Yeah, ignore the 2 there. Minus 1.5. Alright, this one is way above. Okay, we'll use the same formula. So 27.2 minus 20. Gotta do brackets, or else it'll get confused. 3.2. Okay, what does that equal? I'm just going to do 0.2. Okay, 2.25. So that was harder to tell. Okay, hope this makes sense. Let me just see if there's a formula for it. Normal distribution. Here we go, Z-score. Okay, so there's this one. Okay, yeah, that's what I'm using. I don't even need to think about it. That makes sense to me. Notice if you made X the subject, you would, well, I'll just write it here so you know what I'm talking about. X would be, I don't even know the proper way to do this. Okay, plus SZ. So you would, if you knew the Z score and you wanted to find the score, you'd start with the mean and then add the standard deviation times the Z score. Okay, I just times by S and then added the X bar, which is the mean. Okay, I don't know. I just encourage you with these things. You can just look at it, play with it for a while until it makes sense. I can't say much else. And whatever, 16.8. Fine. I'll do that one as well. Actually, that one's easy. I'm just going to write the answer. See how it's below 20 and it's exactly 3.2 below. So it's just going to be minus 1. Okay, you can use the formula though. Okay, Adam got 72. The mean was 65. Okay, I'm going to write the answer again. So a half. I can tell because his score is above 65, so it's positive. But he's only 7 above, but the standard deviation is 14. So he's only half a standard deviation above, so a half. Okay, again, if you want to use the formula, that's fine. 72 minus 65 is 7. 7 over 14, it's just a half. Okay, in a university exam, that means 59. So she's above average. Oh, okay, this one's a little bit trickier. I'm going to get rid of this. Come on, delete. Okay, well, first let's just write this down. 68 minus 59. So she's 9 above average or whatever. Okay, her Z score is 1.5. Now, this 9% is that 1.5 standard deviations. So we need to just do 9 divided by 1.5 to figure out how big is the standard deviation. But that's just 6. So the standard deviation must be 6. Okay? And then that makes sense. If the standard deviation is 6, she's a bit more than that. She's 1.5 standard deviations above the average of 59. Okay? So standard deviation is 6. I can write here S equals. Let's keep going. Patrick's mark. Okay, minus 1.5. Easy. We can even do this. Again, I just encourage doing steps in your head. Well, I'll write a formula. Minus 74, but is less than that, is 1.5 lots of 4 less than that. So, yeah, okay, just remember, so Z-score tells you where their score is relative to the mean. Minus means it's below, and 1.5 is how many lots of this. So 1.5 of 4 is 6, because half of 4 is 2. Add that to 4, you get 6. Take 6 away from 74, you get 68. Okay, that's his exam mark. Okay, quiz has those results. Okay, I may need to skip this because I don't have a calculator with me. If I had to estimate the mean, I'd say maybe, it's really hard to tell, 12 or 13, something like that. And the standard deviation might be 3 or 4. Yeah, it's hard to tell. The Z score. Okay, so the lowest score would be 9. No, 7. Okay, I'm going to estimate it for now. I know that's not ideal, but I can't do it at the moment. It's just awkward. So let's say I'm just going to assume the mean is, let's just assume 13. No, I'll go with 12. And let's assume the standard deviation is, should we go with 3? I'm going to go with 3. Yeah, okay. I'm just estimating. Okay, so let's say, actually, look, to make it more realistic, let's say it's 2.88 or something like that. So we get a decimal, and let's say the mean is 12.1. Okay, now you sort of need the formula. Now it's not so obvious. So she got the lowest score, so 7 is what she got. So the Z score, we need to do 7 compared to 12.1. So her Z score will be negative, and compare it to the standard deviation. So hopefully this works. I'm just guessing the numbers. Okay, that makes sense. Minus. So that's why my standard deviation is probably not big enough. But let's just keep going with this. Because really, her Z score should be close to -3, usually. The lowest. Those should be the extremes. Okay, so if his score was 2.3, a Z score of 2.3, okay, so his mark should be, take the mean, 12.1, and then add 2.3 lots of the standard deviation, okay? Again, this is all just estimate, but the formula is correct, so, okay, 18.724. Yeah, we'll just do 18.7, actually. So just one decimal. So that seems alright. I think my mean is probably a bit low. It probably should have been a bit higher. Maybe the standard deviation, so I'm estimating. But if you have a calculator, try to do it with the statistics and you can see if I'm close or way off. Okay? Alright, let's keep going. 78 in English. Okay, those are our marks. So Z score for English, we're going to compare. She got 78, so let's just use the formula. So her mark compared to the mean, and then divide by the standard deviation. That's 12 out of 15. Okay, so I can tell it's 0.8. I'm pretty sure that's right. Yep, okay, so for maths, so actually again we can maybe do sort of a, I'll write it like this: English, maths. Okay, Z score is 75. Wait, 75 minus 65 compared to the 10. Okay, that's just 1. I'm pretty sure, because she's just 10 above. It's funny, I don't know if they're just trying to be like positive about this stuff, because everyone seems to be above average. There's not many below. Okay, oh, okay, she's below for this one. So she got 68. Oh no, she got 77. So see, it's always like this, students getting really good marks. Okay, so she was 9 marks above, compared to 6 is 1.5. Okay, by all means use the calculator. Make sure you do the top part first, before dividing by 6. Just thinking, yep, okay. Her best result was science. So even though her mark was higher in English, compared to the mean and how spread out the marks were compared to her peers, science was her best result compared to her peers, or the test itself. I don't know. Let's just say compared to her peers, but I guess the average reflects the difficulty of the test. So anyway, the science result. Okay, so her mean is going to stay as her Z score is going to stay as 1.5. So her new mark will be, so the mean is 72, and then 1.5 lots of 8. So half of 8 is 4, add that to 8 is 12, so 72 plus 12 is 84. So if they do things like this, they can modify, if there's a test that's too hard, they can keep everyone in the same order and just shift the marks up. Or if it's an easy test, shift the marks down. Can be done. Alright, Riley scored 74. Okay. Okay, so same thing. We're just going to find the Z scores nice and quick. So we need to, again, they got above average every time. So compare that and divide by 5.1. That one's not as easy. I'll write the formula for the other. Please try to do it yourself as well. So they got 80 compared to 74.1. Need to divide it by 8.1. Okay, and I probably should label it. So this is literacy. I'm just going to write it like this. Okay, and numeracy. Alright, calculator. 74 minus 67.6. Okay, 1.25 will do. Okay, 80 minus 74.1. Okay, 0.73. Why did it do that? I want it in the formula. Okay. Alright, so the better mark was in literacy compared to the average or whatever. Okay. A normal distribution. Okay, mean and standard deviation. Okay, 68% of scores, that's between -1 and 1. Let's just go back to this. -1 to 1. In fact, the other two numbers are the next two. -2 and 2, -3 and 3. Notice those are the percentages that we got. So let's get rid of all this stuff. You can copy it later if you want, or before. Alright, so if we do 136.5, if we add a standard deviation, see what we get. 145. Okay, I think that's the highest, and 136.5. If you take away 18.9, 18. Okay, so basically between whatever, 68% of scores should be between 117.6 and 155.4. Okay, hope that makes sense. So 68% is between -1 and 1 in terms of these standard deviations. Let's just do the next one. If you basically, if you change this to 2 lots of that and 2 lots of that. So sorry, let's do it like this. Okay, so 2 lots of that and 2 man, come on, 2 lots of that. Then this will be the other ranges. So let's just quickly do it again. In fact, it might be best to just figure out all these numbers first. You got that number, add 18.9, add 18.9, so 174.3. I hope you know what I mean. Actually, look, I'm just going to do that. Let me get rid of all this. I just decided this would be easier. That's correct, but let's put 136.5 in the middle. Okay, so then we've got 155.4, and we've got 174.3, and then let's add 18.9 again. It's actually probably easier with a calculator. 193.2. Okay, so this is the Z scores above. So that's 1, 2, 3. This is 0. Here, let me actually quickly. This shouldn't take too long. I think I want 7 actually. Let me. I can't pause it. Hang on. Let's bring this over. I wish it would make these columns smaller. I don't understand why it needs to be so. This must be a quicker way. Hang on. Let's watch this. I'm gonna figure this out. Here we go. Let's change the width. Okay, that's better. So I'm going to put these here: 136.5, 155.4, 174.3, 193.2, 3. Let's start from here. -3, -2, -1, 0, 1, 2. Okay. Don't worry, we're gonna get there. We're gonna get there. And this one was 117.6. Okay. Okay, and then take away 18.9 again. Take away 18.9 again. Alright. So this is 98.7. And this is 79.8. Okay. Now that we've got all these numbers, now the answers are easy. Sorry if that took a bit of time. So between -1 and 1, we've got those two numbers, that range. Let's just center all of this. Thanks. Alright. The next thing is 95% of scores should be between, I don't know if I need to write that out, between -2 and 2. So 98.7 and 174.3. Okay? And then 99.7% should be just say between 79.8 and 193.2. Okay? Might not be that exciting with this subject, but that's how it works. -1 to 1, -2 to 2, -3 to 3. Just keep in mind, by the way, all this Zed Score stuff, standard deviation, it is actually true. It does actually make sense. Oops. Hang on. So, and it does apply to any data. Like, it's not exact, but on average, the data will tend to be like this, like with these percentages in that range. Okay, next one. A normally distributed has a mean. Okay, this is tricky. This one's easy. I know the answer because I can see these numbers are special. 9.1 is just 0.8 below it, and that is 0.8 above it. So it's between -1 and 1, so that's 68%. What I might actually do is do the same thing. Let's just do the same thing now that we've gone to that effort. Okay, so I'm just going to change these numbers. Cool. So in the middle we've got 9.9, and then we're going to go up by 0.8. So I'll get 10.7, 11.5, 12.3, I think. I don't always trust myself with this stuff. 8.3 and 7.5. I think that's right. Okay, let's just assume. Okay, so we've got that. So yeah, between here and here is -1 to 1. So the answer to that is 68%, just because we know that's the rule between -1 and 1. Okay, 7.5 is here and 12.3. So that's this one. Okay, between -3 and 3. So the answer to this one is 99.7%. Okay, this one 11.5 and 8.3. I don't know why they're doing it the other order. That's -2 to 2. That's 95%. Okay, 11.5 and 12.3. This is much trickier. Now they had a drawing before that we could probably use, but what I would do if we're not sure, let's just say basically we're gonna halve. How can we do it? If we do, some of this stuff really is just tricky. Hang on. Okay, so let's say we do 95. I'm going to divide that by 2. That's 47.5%. Okay, that's how many are between 0 and 2. Okay, that's from 0 to 2. And then if I do this one, 99.7 divided by 2, 49.85, that's from 0 to 3. Okay, I hope that makes sense. You just halve it. If you halve it instead of being between -3 and 3, it's between 0 and 3, or 0 and 2. Now, if we take the difference between those two, that'll tell us how many in this range, between 2 and 3. So, again, I don't know, maybe you're meant to use a different method, because this can be a bit confusing. 2.35%. Okay? So 2.35% should be between these two numbers. Okay? 8.3 and 9.1. Again, that's tricky. Let's also add here 68 divided by 2 is 34% from 0 to 1. Okay, but this is also, so see where 8.3, so for 9.1, let's just imagine, so between 0 and 1 is 34%, but also in this range, that's 34%, and from 0 to 2, it's the same as this, is 47.5. So this is 47.5, and this is 34, so we just need to subtract for this part. I don't know if this is going to make sense. Hopefully it does. I know what I'm doing. 13.5%. Okay, that's the answer to this one. 8.3 to 9.1, there's going to be 13.5%. Let me just, for reference, so that we know what we... Yeah, so see, I actually figured out these numbers. Okay? It all comes from these things, 68, 95, 99.7. If you break it up into parts and subtract, to get like between 2 and 3, you just need this part, 0 to 2 and 0 to 3, and you subtract, you get this number. But anyway, so it does make sense. In fact, I don't know why they don't give you this in the test. Maybe they will. Alright, where were we up to? Okay, 9.9 and 12.3, that's easy, it's just 0 and 3, so it's this number, 49.85% for that one. Alright, how's the time going? I don't want to go forever. Jeez, this is a long one. Okay, they have 2 kilograms. Okay, greater than 2.06. Okay, so that's a bit above that. In fact, the difference is 0.04 between these two, which is 2 lots of that. So this has a Z score of 2. So how many have a Z score higher than 2? Yeah, again, I know how to do it. Okay, so let's take this one. This is from 0 to 2. Okay, and let's also add 50%, because anything less than 0, that's 50%. So if you, I'm going to get rid of this part. Okay, if you do 50 plus 47.5 is 97.5%. Hang on. And that's up to 2. Up to a Z score of 2. Okay? Maybe here let's write, so why does it do that? 2.6 kilograms has a Z score of 2, because that's how far above the mean it is. Okay, so the answer to this first one is what's left over from that. So it's 100 minus 97.5, so which is 2.5%. Again, I think it's easier if you know that it's above 2. Above here, you just add 2.35 plus 0.15. If you add that, you'll get 2.5%. Okay? Alright. Let's see. Less than 1.98. Okay, again, that's below this. And it's actually just 2 lots of this below. Alright? So that Z score is -2. So the answer to this is actually the same as that. Okay, so it's sort of like how many above 2 is just this plus this. How many below -2 is just that plus that. It's the same though, it's symmetrical. So the answer is again 2.5%. Same answer for that one. for that one. Okay, between 1.96 and 2. Oh my goodness. Okay, so that's 3 below, 3 standard deviations below, and that's 1 above. I'm going to encourage using this thing now. So between -3 and 1, so just these, can't highlight this one, this one, this one, this one, add those 4 together. So it'd be 68 plus whatever, 81.5, 83.85, something like that. 83.85%. Okay? If they give you questions like this, I reckon they'll give you that graph thing. Alright. Blood pressure. Oh, the number of people. Okay, we better do this. Between 100 and 120. So notice the standard deviation is 5. So 100 below 110, and it's 2 lots of 5 below. So that's a -2. The Z score is -2. This one is above, and it's 2 lots of 5 above. So the Z score is 2. So between -2 and 2, I'll just use the formula sheet for this one, 95%. Okay, so if it's 200 people, I'm going to get rid of all this bit. 95% of, well, let's times it. So let's do 200 times 0.95. It should be 190 people. That's the answer to A. Okay? If it's between 105 and 120, 105 is just a Z score of -1, and 120 is a Z score of 2. So again, I'm going to just refer to this thing. So between -1 and 2 is these 3 parts. Okay, so 68 plus 13.5 is 81.5, I think. Whoops, why did I? Oh gee. Okay, so 81.5, so we're going to do 81.5 over 100, or 0.815. Okay, so that's going to be 163 people. Okay, for this one, less than 100, okay, so that's less than a Z score of -2. So again, I'm going to use this. Less than -2 is just these 2 parts, which adds to 2.5%. Okay, matches with the previous question. So again, find 2.5% of 200. So I'll do 200 times 0.025. I think that's 5 people. And then more than 115. So that's more than a Z score of 1. Okay. Whoops. So more than this, you can add these 3. Okay, but that should be, I can't even think. 5, 16. Yeah, 16%. So again, you just find 16%, 200 times 0.16, 32 people. Alright, so that's the answers, okay? Even if this is a bit weird and crazy, if you take your time, look through that, try to look at that graph, the diagram, it does make sense, okay? Factory makes pistons. Okay, so 99.7, I recognize that. That should be between -3 and 3. So let's look at, okay, let's quickly do a table again. Copy, paste, alright. These numbers we get rid of. So in the middle, we've got 70 millimeters. And then, gee, this is tiny, 7.002, 70.004, 70.006. Okay, I'm pretty sure that's right. And then we've got here 69.998. Okay, I'll go Here's 69.994. Okay, so that's our sort of Z scores. So 99.7% should be between 69.994 millimeters and 70.006 millimeters. Okay, so that's the answer for A. Between these two endpoints, what percentage will have a diameter greater than this? Okay, so greater than 1, what percentage? 16%. Okay, from memory. Let's just again look at this. So greater than 1 is this plus this plus this. They add up to 16%. How about, look, I'll write it out. I feel like maybe I should write these out a bit more. So between 69.994 millimeters and 70.006 millimeters. Okay, for B, it was what percentage? 16%, because it's a Z score of 1. What percentage will be less than this one? Very, very small. I remember it from the diagram, 0.15%, I'm pretty sure. Let's just double check so I can show you. This one. This means anything less than -3. Okay. Okay, if they made 600, how many would you expect to be undersized by at least this much? So from here, so less than -2. So again, let's double check. I'm starting to remember these numbers. Less than -2 is this one plus this one, so 2.5%. Okay, so 2.5% of 600, which is, we'll do calculation, 600 times 0.025, which I should be able to do it by myself. 100 times that, 5 times 6 is 12, so 15 pistons. Okay, alright, finally got through that. Okay, so other than the ones with the calculator, I consider that a separate skill, so if I can, I'll make a video about that, but it's hard to show you that. I know the steps, it's easy to show you in person. Okay, so I hope that helped. I don't know, that's a crazy topic. Let me know if you're stuck. Bye.